Explorer-1, NASA's farthest traveling spacecraft, continues its journey across uncharted regions of the universe nearly 50 years after its launch. Recently, researchers have been puzzled by unsettling data the spacecraft is transmitting back to Earth, seemingly due to a malfunction. Join us as we explore the strange information that Explorer-1 has been sending during its ongoing space mission. The quest to understand the domains beyond our solar system began with the launch of Explorer-1 and Explorer-2, among other missions, inspired by the mystery of the Big Bang. Explorer-2, the first of these spacecraft, launched from the Kennedy Space Center on August 21, 1977. Just 2 weeks later, on September 5, Explorer-1 followed suit. Despite being launched as twins, the spacecraft took different paths and traveled at different speeds. By December 15, 1977, Explorer-1 had passed Explorer-2 and has since become an invaluable resource for learning about distant realms of space. Explorer-1 began its Jovian imaging mission in 1978, about 265 million kilometers from Earth, sending back a wealth of data. During a remarkable 100-hour stretch in January 1979, it captured 3,750 images of Jupiter's rotation, producing a time-lapse film showing 10 rotations of the planet. It also discovered a faint ring around Jupiter and 2 new moons, Phoebe and Métis. Explorer-1 continued to provide valuable insights during its flyby of Saturn, identifying 4 of Saturn's moons, including Mimas, Enceladus, and Tethys. After completing its planetary missions, both Explorer-1 and Explorer-2 were sent beyond our solar system, traveling at 325 million kilometers per year. In January 1990, Explorer-1 embarked on the Explorer interstellar mission. One of the most iconic images taken by Explorer-1 on February 14, 1990, was the family portrait of our solar system, captured when the spacecraft was 6 billion kilometers from the Sun. The spacecraft took 60 photographs of the Sun and planets, bringing its total number of images to 670. The spacecraft's cameras were powered down to conserve energy before continuing its journey into interstellar space. Explorer-1 continued its journey for another 14 years, passing the farthest spacecraft, Pioneer 10, on February 17, 1998. Finally, on August 25, 2012, Explorer-1 entered interstellar space, though NASA did not publicly announce this milestone until 2013. By November 2018, both Explorer-1 and Explorer-2 officially crossed the heliopause and entered the interstellar medium. As of now, Explorer-1 is located about 145 billion kilometers from Earth and continues to send valuable data back from the unseen regions of space. Despite its successful mission, Explorer-1 has recently been sending strange signals, leaving researchers baffled. While the spacecraft's antenna appears to be in good working condition, the data it is transmitting seems inconsistent with its actual operations. It continues to receive and follow commands from Earth, yet its control system doesn't reflect what is happening on board. According to a NASA official statement, this discrepancy has left scientists with more questions than answers. Each spacecraft heading into interstellar space, including Explorer-1 and 2, carries a 12-inch gold-plated disc containing sounds, video messages, and greetings in 55 languages, in case it is ever discovered by an alien civilization. However, speculation about the spacecraft being taken over by extraterrestrials has been swiftly dismissed by scientists. The spacecraft's operations rely heavily on its attitude and communication systems, which are still functioning as expected, adding to the mystery. Currently, the spacecraft is experiencing some anomalies, but the safety features designed to protect it from potential hazards have not been activated. Susan D., the task manager for Explorer-1, acknowledges that the spacecraft is much older than originally anticipated, and the engineering team faces significant challenges in resolving the issue due to the vast distance between Earth and the spacecraft. Despite these challenges, Explorer-1 continues its remarkable journey, offering us new insights into the unknown regions of space. The spacecraft's orientation is controlled by the Attitude Control System, ACTS, which regulates its positioning and communication. Engineers monitoring the situation currently believe that the ACTS is functioning properly, which only adds to the mystery they face. None of the spacecraft's safety systems, designed to protect it from potential risks, have been activated, as noted by Susan D., the project manager for Explorer 1 and 2. This enigma is not uncommon for the Explorer mission, considering the spacecraft are both approximately 45 years old, much older than originally anticipated in the mission plan. Susan D. acknowledges the significant challenges the engineering team faces in resolving the issues with Explorer 1, primarily due to the immense distance between Earth and the spacecraft. The spacecraft is currently about 145 billion miles away, which presents substantial difficulties. This vast distance complicates the troubleshooting process, as Explorer 1 is well beyond the range of any spacecraft or repair mission that could realistically be sent. Explorer 1's journey has taken it into the outer regions of our solar system and beyond, into interstellar space, where it continues to travel farther from Earth every day. Messages from Earth take nearly 21 hours to reach Explorer 1's current location, meaning any commands or instructions sent to the spacecraft will be delayed for this amount of time. This communication delay poses a major challenge for real-time problem-solving and troubleshooting. Furthermore, once Explorer 1 receives a command and processes any data or responses, it takes another 21 hours for the information to return to Earth, resulting in a total communication delay of approximately 2 days. This delay makes it incredibly difficult to implement quick solutions or iterative troubleshooting, which are often necessary when dealing with complex technical problems. As a result, the engineering team must carefully plan and execute each command, anticipating different scenarios and outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Every instruction must be meticulously crafted to address known issues without introducing new problems, given the extended time required to confirm whether the command has had the desired effect. The communication delay also limits the engineering team's ability to interact with the spacecraft, leaving minimal room for error. Each command must be precise and effective, necessitating thorough testing and validation on Earth before being sent to Explorer 1. Despite these logistical challenges, the spacecraft itself is over 4 decades old, having launched in 1977. While the technology on board was cutting edge at the time, it is now considered outdated by modern standards, adding another layer of complexity to the troubleshooting process. The harsh environment of space has also taken its toll on the spacecraft's systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for more than 45 years, contributing to wear and degradation of its components. These factors make maintenance and repairs even more challenging. Despite these obstacles, the engineering team remains dedicated to resolving the issue. They are exploring various theories about the possible causes and testing potential solutions through simulations on Earth. This careful, methodical approach is crucial, given the high stakes. Any erroneous command could exacerbate the situation or result in a loss of communication with the spacecraft. The team is also relying on the redundancy built into Explorer 1 systems, such as backup systems that were included to enhance the spacecraft's resilience to failure. The team may be able to switch to these backup systems or reconfigure existing components to bypass faulty parts. NASA has stated that until the cause of the issue is better understood, the team cannot predict how much longer the spacecraft will be able to gather and transmit scientific data. However, Susan D. and the team are confident that the issue will eventually be resolved, assuming it is something that can be fixed by the attitude control system, which governs the spacecraft's orientation and communication. This situation, while difficult, has not been completely discredited by scientists. Explorer 1's ability to function relies heavily on the ACTS, which keeps the spacecraft's antenna pointed toward Earth for accurate data transmission. It also controls the spacecraft's position, and engineers are currently confident that the ACTS is working properly, adding to the puzzling nature of the situation. Despite this, none of the spacecraft's safety systems have been triggered, and the enigma persists as the team continues their investigation. Explorer 1 is currently situated about 145 billion miles from Earth, a distance that brings several challenges that must be approached with great caution. The idea of salvaging the spacecraft seems nearly impossible due to the vast mechanical and logistical requirements. Having traveled far beyond the reach of any shuttle or potential repair mission, Explorer 1 is now in the outer regions of our solar system and into interstellar space, continuing to move further away from us every day. Messages sent from Earth to Explorer 1 travel at the speed of light and take about 21 hours to reach the spacecraft's current location. This means that any commands or instructions sent from the engineering team take a considerable amount of time to arrive. This delay presents a significant challenge for ongoing problem-solving and exploration. Once Explorer 1 processes the command, it will take another 21 hours for the spacecraft's response to reach Earth. This means two-way communication between Earth and the spacecraft takes approximately 2 days on average. The time delay makes it extremely difficult to perform practical troubleshooting or iterative investigation, both of which are often essential when dealing with complex technical issues. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay necessitates a more strategic and patient approach. Every instruction must be carefully crafted to address known issues without introducing new ones, as there is little immediate feedback on whether the command had the desired effect. The limited opportunities for communication mean that every command must be precise and effective, leaving little room for error. This demands extensive testing and validation of commands on Earth before they are transmitted to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 40 years old, having been launched in 1977. While the technology on board was state-of-the-art at the time, it is now considered outdated by modern standards. The engineering team must work with equipment and systems that were designed and built in the 1970s, adding another layer of complexity to the problem-solving process. Furthermore, the harsh conditions of space have taken a toll on the spacecraft's systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroid impacts over the course of more than 45 years, causing wear and degradation to its components. This makes it even more challenging to maintain and repair. Despite these difficulties, the engineering team remains committed to solving the current issues. They are exploring various theories about the cause of the anomalies and testing potential solutions through simulations on Earth. Given the high stakes, this cautious approach is crucial. A wrong command could exacerbate the situation or result in a complete loss of communication with the spacecraft. The team is also making use of the redundancy built into Explorer 1 systems. Like many space missions, the spacecraft was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems or reconfigure existing components to bypass the problematic parts. NASA has stated that until the cause of the issue is better understood, it is impossible to predict how much longer the spacecraft will be able to gather and transmit scientific data. However, the engineering team remains confident that the issue will eventually be resolved. If any part can be fixed, particularly the attitude and orientation control system, which is essential for maintaining the spacecraft's communication with Earth, the spacecraft's ability to continue its mission could be restored.